Hello everyone. Today we are going to discuss the second case of graphing exponential function transformations, that is graphing vertical shift. In our previous lecture we have discussed about the horizontal shift. Now I'll tell you today that what is the general form of the vertical shift exponential function, and what is the example of that vertical shift, and how you can plot this on the graph, and how you can distinguish between the parent function and the vertical shift exponential function. So first of all, I will discuss about the general form of graphing the vertical shift exponential function. Its general form is f of x is equals to a dot means it is multiplying b raised to power x plus k, or f of x is equals to a dot b raised to power x minus k. So these are the two general forms of the exponential functions with the vertical shift. Now what does that mean? This is a generic form. Let me tell you one by one these values. F of x is basically the y, or the output of the function. This is the y-intercept, you can say, or the scaling factor. B of x is the base. As I already told you, on the basis of this base you will decide whether the exponential function is growing or decaying. X is the input to the function, the value of x, and k is the constant that will determine the vertical shift. So this constant will determine whether the shift will be upward or downward. Keep this in mind, that the vertical shift will be on the y-axis. It has nothing to do with the x-axis. You will find the change or the impact of this shift on the y-axis, because this we are adding or subtracting k from the function, so it will impact the output, that is y. So if there is a positive k, it means that the shift is upward. If I write here, plus k represents upward shift, it means you are adding something to the y value, so it is going up, and then minus k is the downward shift. It means that in the exponential function, when you came across some constant is adding or subtracting, keep this in mind. Don't get confused with this addition of the constant. We are adding this constant to this whole values, to this whole function. We are not adding this constant to only the exponent, that is x, that we have done before in the case 1. In the case 1, we were adding or subtracting from the exponent value of this function, that is b raised to power x plus h, or x plus or x minus h. But here we are adding k to the whole value of this function, that is a dot b raised to power x plus k, or a dot b raised to power x minus k. So this is how it differs from the horizontal shift. Now let's have an example that will clear your idea more about it, that whenever you came across the examples like that, you should quickly have the idea that this is basically a horizontal shift. So the example is, the parent function is, I will represent the parent function with the purple color. So the parent function is f of x is equals to 2 raised to power x. This is the most simplest example. Then another type is f of x is equals to 2 raised to power x plus 2, and the another function is f of x is equals to 2 raised to power x minus 2. Now keep this in mind, these are the two transformations of the parent function f of x is equals to 2x, and these transformations are just repositioning the original graph. It is not impacting the shape of the graph. It is just repositioning it on the coordinate system. So adding or subtracting, it's just adding or subtracting a constant value in the original function. The function will move up or down on the vertical axis. So on the basis of the constant value, so it is clear here that this 2 is representing k, and here this 2 is also representing k. So this is basically a shift. It means the original function is shifted by 2 units in the 2 raised to power x plus 2, and similarly it is shifted by 2 units in 2 raised to power x minus 2, but one is in the upward direction and the other is in the downward direction. I have separated these two transformations of the parent function f of x equals to 2 raised to power x. In one transformation, a constant is adding, and the other, the constant is subtracting. So in this transformation, that is where the constant is adding, that is plus 2, the function f of x, that is the original function, is shifting 2 units upward. So this is the information that you should know before plotting the transformed exponential function. So whenever you came across the function like this, it should click in your mind quickly that this function is transforming the original function 2 raised to power x by 2 units in the upward direction on the y-axis. And similarly, the f of x, that is 2 raised to power x, is shifting 2 units because k is 2 units downward on the y-axis. So the original function will remain the same, just its position will be changed. So let's draw some points on the graph so that you can see how they differ graphically as well. So first of all, we will plot the parent function f of x is equal to 2 raised to power x. So I am not writing the points of f of x equals to 2x. I am just drawing it on the graph. I'll just write the points of the transformed function xy here. So first of all, I am going to plot f of x equals to 2 raised to power x. You can take any random values of x and x so that you can get the y. So I am taking the range from -2 to 3. So if we put -2 in the given f of x equals to 2 raised to power x function, I will get 0.25. So the point will be somewhere here. Another point is on -1. The parent function f of x equals to 2 raised to power x will give you 0.5 here. Then its y-intercept will be here. On x equals to 1, the y will be 2. Then on x is equals to 2, the y will be 4. On x is equals to 3, the y will be 8. So if I join them together, I'll get the parent function. So this is the parent function f of x. This is f of x is equals to 2 raised to power x. Now I have to plot the transformations, that is the f of x is equal to 2 raised to power x plus 2 and f of x equal to 2 raised to power x minus 2. For that we need to plot the points as well so that we can see the difference between them, that how we by adding 2 how it is shifting to in the upward direction or the downward direction. So we are again taking the same points that we have taken in the parent function. So it will be -2, -1, 0, 1, 2, 3, 4 up to so on, and the corresponding points for 2 raised to power x plus 2 will be 2.25. It will be 2.5. On 0 it will be 3. On 1 it will be 4, on 2 it will be 6, on 3 it will be 10, and on 4 it will be 18, and so on. So similarly in the case f of x equals to 2 raised to power x minus 2, we will get the random points. Next we are going to plot f of x equals to 2 raised to power x plus 2 first. So I will use the blue color for that. So on -2 it's 2.15. It will be a point here. Then on -1 it's 2.5. Okay, a point a bit above it. Then on 0 it's 3, it's the y-intercept. On 1 it's 4, and then on 2 it's 6, and then on 3 it's 10. It's going upward. So if I join the points together, it will be like so. The shape is same, it is just translated or shifted vertically on the y-axis upward due to the addition of 2 units in the original function, as that here in the general form of the exponential function, as 2 is we are adding 2. This function is f of x is equals to 2 raised to power x plus 2. So it is clear here that the y-intercept is also shifted 2 points upward, because in the y-intercept of the original function was at 1, and here the y-intercept is 3. So it means 2 has been added in the y, so it is being shifted upward. The next one is the 2 raised to power x minus 2. Now we will plot that. For 2 raised to power x minus 2, the first point is on -2 we have -1.75. So the first point will be here. Then on -1 is -1.5. Second point will be here. Then the y-intercept is -1. Then on 1 it's 0. Then on 2 it's 2. And then on 3 it's 6. And then on 4 it's 14, and so on. So if I join these points, it will be like so. It means that the function, that is f of x is equals to 2 raised to power x minus 2, has been shifted vertically downward, and because 2 units has been subtracted from the original function. The original function is the purple one, and when you subtract 2 from it, it is the output has been shifted downward 2 units. So it is clear here that the y-intercept is now -1. So this is how the both of the shifts behave in the transformations of exponential function. So keep this in mind whenever you came across such forms, that is 2 raised to power x plus 2, 2 raised to power x minus 2. Keep this in mind. This 2 is being added in the y rather than x. That's why the shift is vertical. The impact is on y-axis rather than on x-axis. So this is all about graphing the vertical shift. That's all from today's lecture. Thank you.